in the coefficient and the constant and the sum. Alright? Well, let's use what we know about buck. Let's box the question. How many hours? So we know our answer must be in hours. So it must be x equals some. Okay? Because I'm telling you that the x, which is the variable, is the piece we don't know. We don't know how many hours. So when we build the equation, are we finished? No. We've got to actually solve it too. Alright? What's the coefficient going to be? What value down here is dependent upon that x?
350.
You say 350? Well, let's look at what we got. We've got $7.65 for each additional hour. We've got $15 for the first hour, and we've got 350, which is the total. Let's take it line by line. They decided to charge $15 for the first hour. Where would that $15 go? Is it the coefficient? Does it have anything to do with the hourly rate? Is it the constant, because it's going to always be the same? Or is it the sum? It's the total amount they need. What does the $15 an hour fit in?
Wait.
It's the constant. Notice the language. It's $15 for the first hour. That means that rate is going to be constantly the same. Everybody's going to get charged $15 for the first hour. Everybody. Everybody. But for each additional hour, how much do we charge? $7.65. What you're seeing now is how the coefficients and the constants can be decimals and fractions now. And all of that is equal to a total of what?
$350.
Yeah, and it makes sense because normally our total is our biggest number, right?
Yes.
Do we have an equation? Do we have a coefficient?
Yes.
Do we have a variable?
Yes.
Do we have an operation?
Yes.
Do we have a constant?
Yes.
Do we have an equal sign?
Yes.
Do we have a total on the end?
Yes.
Can I solve this equation for x now?
Yes.
The first thing I need to move, so I'm going to make this a little bigger. $7.65 times x plus 15, and I can take off the dollar sign, equals 350. There's a multi-step equation, or a two-step equation. What's the first thing I need to move?
The constant.
The constant. What's the constant, people? Everybody? 15. Move it where?
Underneath.
Some of you need to break it up. Where is this 15 going to go? It's here and where? Under the what? 350. What symbol goes beside it? If I started out adding, I need to do the inverse, which is what? Subtraction. Here and there. Okay? What happens to the 15s? They cross out. Take a symbols with them. Bring down your coefficient and your variable. Your equal sign, what do you see over there? 350 minus what? 335. Or 15. It gives me 335. Alright. What am I left with? I'm left with what operation sits between that coefficient and that variable, people? Multiplication, even though I don't see it. So how can I undo it? What's the inverse? Divide. How do I show division in an equation? Do I use that division symbol? I use a what? Fraction mark. Here? Where else? On this side. And notice this is the left and this is the right. Whatever you do on the left side, you got to do to the right too. What am I dividing by? $7.65. You divide by whatever the what is, the coefficient. Okay? Now, translate to me what we got. On this side, what happens? The coefficients cross out. What am I left with? X equals what? 335 divided by $7.65. Somebody pull out that handy dandy and punch it in there. Somebody.
Oh, but she pushed it.
we get 43.7, but we're talking about hours. So about how much? About how many if I'm rounding to the nearest whole number?
44.
Yeah, 43.7 or about 44 hours. So X, if I asked you to define the variable, what would you tell me the variable equal? The variable is always what we don't know. What didn't we know? How many hours? So if I asked you to tell me what X equals, you would say, Mr. Gray, X equals number of hours. You can always find the description of your variable in the question in your word problem. What is it asking you? That's the part you don't know, because that's what you got to find. That's what your X is going to be. Make sense? Okay. All right. Hand me that towel. Hand me that towel. Have y'all got that down? If you don't worry about it, because it's recorded. It's recorded. Okay. And I'm only erasing this stuff, a bundle. This stuff don't change. It's the same. Okay. It's recorded, so don't worry about it. Do y'all remember this?
Yes.
Did it help? Okay. Now we're going to do the same exact thing in the next problem. Somebody wet that right quick. We're going to do the same exact thing in the next problem, except we're going to use the inequality symbol. Okay? So I'll give y'all time to copy that. All right. Bring me an additional napkin too.
All right.
Now Kenyon, if you'll hit the down arrow and scroll down to the next problem. There you go. Bring it on up. Bring it on up. Go on down a little more. Okay, you might have to take the mouse and scroll down a little bit. Right there. Right there. Go up a little more. Because I need some viewers right there. Right there. Okay. Is that one wet too? Yeah. These word problems, all I'm doing is helping you pull these word problems apart. Okay? Okay. Now, when we start talking about writing inequalities to fit real world situations, we do it the same way we do equations. The only thing that changes here is the equal sign. That's it. Okay? So let's look at this. We're going to do it the same way. Mackenzie and Khalil are babysitting young children to raise money for the talent show at school. These kids do a lot of babysitting. They decided to charge $12.50 for the first hour and $9.50 for each additional hour. If they need to raise a minimum, and you're going to need that chart I just handed you on inequalities. You're going to need it. They needed to raise a minimum of $425. How many hours would the girls need to babysit? Okay? We're going to need that chart. Think about where you see the word minimum. What inequality symbol is it sitting beside? Don't yell it out. That's probably the one you're going to need to use. This table lists the crack in the math code terms that we associate with equations for inequalities. Okay? Let's build it. What won't change in the equation? The x. Exactly right. Show up. The x. Bring down the plus sign. I think we're adding. We might not always add. The general form will start out with the addition, but you may end up subtracting one day in an equation. We've seen them like that.
It say how many.
Okay, say how many? But it's saying how many hours. So that is our what? Say it, Jacorian. X. It just told us what we didn't know. We don't know number of hours what? They babysit. They need to babysit. And all you're doing is telling me what X is. Because I'm going to ask you that, define the variable. That's giving me a description of what we don't know. Okay? What's the constant going to be? Is there a rate in that problem that's always going to be the same?
Yes.
Huh? $12 and what? 50 cents for the first what? Hour. She's going to charge that regardless. I don't care if it's family, if it's the best friend, if it's President Obama. Everybody's getting charged $12.50 for the first hour. So that's constantly the same.
No, 50 would go under the A.
Okay?
And then
What would A be? How much is she charging per hour?
$9.50.
$9.50.
And 425 going to C.
And because that's my total. But I see a problem. What did Mr. Gray stick right there? Should I supposed to do that?
No.
We're doing an inequality.
Take it out.
What should it be? What's the crack in the math code term in here? What term or terms do you see on your chart that fall up in here?
Less than.
Do you see less than in there? No, I see one key word, minimum, that I see on this chart. Don't you? Do you see any more? It has to be just as you see it. Not just one word. If it's a phrase, you need to see that exact phrase in the word problem. Where do I see the word minimum? What beside what symbol? Think about it. Does it look like this?
Yeah.
Does it look like that on your chart?
Yeah.
Do you see it? Circle it. Circle the word minimum and circle the symbol that it sits beside. Okay? How do you say that symbol? I think some of us don't know how to say it. Who? There you go, baby. Greater than equal to. So this side has to be what? Less than equal to. Doesn't this one look like a bent L? Eyes on me. Pencils down. Don't that look like a bent L? So that's the less than symbol. This one, if you think about the G, this side looks like the hook on the G. So it's the greater than. Do you get it? Okay, I hope you do. Okay? Do I have my equation now?
Yes.
Yes, I have my eyes on me. I have my everybody. I have my inequality, and I have my sum because I'm adding. Now can I solve it? What's the first thing I'm going to move? Everybody.
Constant.
What is the constant? Everybody. $12 and what? 50 cents. I'm moving it to, and I can still split them up. Moving it to both sides. $12 and 50 cents. Notice how I line that up. Where's the decimal in the 450? Behind the what? Where's the decimal place in any whole number? It's behind the ones place, and in this case it's a 0. Just in case you wasn't making those connections. Okay, good thing it's recorded. What symbol goes beside it? Subtraction. Why? It's the inverse of what? Addition. Okay. Cross these out. What comes down? The $9.50 X is greater than or equal to, what's $450 minus $12.50? Should give us about $437.50. What am I going to do now?
Put a fraction bar in it.
Fraction bar. What does that tell me to do?
Divide.
Divide. On both sides?
Yes.
Here and there. What goes up under it? 950. These cross out, as Khalil just said. Bring the X down. I'm going to do it down here. And, can you see that? I'll do it over here. X is greater than or equal to, translate that for me. $437.50 divided by $9.50. And that's going to get, my answer is going to give me what? Number of hours. What you get? About 46. It's 46.0 something, so about 46 hours. Okay. Make sense?
Yes.
Did you need that reminder? I figured you did. Okay.